where this part is to be very important. Like just I was telling that the product realization, so product is very important, but we cannot go directly taking that product. For example, if you want to make a glass, okay, so before that you have to select the material, you have to go for the designing, the dimensions, the drafting, everything is to be, and then we can go for the final product, right? So traditional product realizations, in case of this, you can see in the slide also, where the engineering product frequently involve component more than one discipline, which I already explained to you. And the next one is a better but still deficient approach, like the discipline specific concurrent program designed for the manufacturing. And the bottleneck is some optimal integration is to be required, because what exactly you have to synchronize the integrate the different components in one single form. Like the basic example, we can go for the shaft, that the in the shaft, like that the it is to be our crank and shaft, where it is to movement is there, we have to put into the particular hole conveyor, or you can take the example of the conveyor where the pulleys is there, and that we have to hole and shaft is to be there, that is to be fixed. Okay, so this is the part is there, and some integration where it is to be adding something, you have to connect from one place to another place. So these are the deficient approach can be product realizing paradigm. And in case of this, you can go for this discipline is design and manufacturing, not only limited to the mechanical, it may go for the electronics, communications, and the computer science, electrical, and some of the part is civil also, in most in some of the cases. And the next one is the mechatronics based product realization exploits, where integrated process founded up to interdisciplinary synergy. See, this interdisciplinary is not only because when we are just taking the, we are going for the definition. That time you was seen that it is defined the mecha and in electronics, like, but after some changes and the modifications comes, that some other part, the mechanical and electro, not only that two integration is to there, it is also included in the some other field also. So now it is, you can say, multidisciplinary or interdisciplinary also. Disciplinary foundation of mechatronics is that already we have discussed the mechanical engineering, electrical, computer, or information technology. Multi-cross interdisciplinary is there, where the product and process requiring input from work more than one discipline can be realized through the following types of interaction. So these are the interactions we have listed for the multidisciplinary, cross-disciplinary, interdisciplinary. So what exactly is that we will discuss today? If we looking for the multidisciplinary, it is nothing but this is a additive process. This is nothing multidisciplinary. If you are talking about the multidisciplinary, this is an additive process of bringing multiple disciplines together to bear on a problem. See, when you go for the example, for just taking the example of the vehicle, automobile or two-wheeler, so it is not only limited to the one part of the mechanical. Some self-start is there, but mechanical engineering and some programming is there. Now with driverless car is there, so we need to do the program. So when go for the application is not limited to the single part, right? That is multidisciplinary part is to be there. So in the multidisciplinary, when you are talking about the application, what exactly we have to do? We have to combine, means we have to provide each and everything under one umbrella, right? It is not like that this part is to be covered by the mechanical engineers, that will be computer engineer, and like that. Yes, that happens. Maybe you can be masters in one field once, it is not, but you have to be little bit knowledge, the basic things is to be very much essential in each nowadays. That is nothing but a multidisciplinary. The meaning of this multidisciplinary is that is already given in this particular word. Just you concentrate what exactly this is. An additive process of bringing multiple discipline. Multiple means it may be one or more than two, right? So that depends on the application, what exactly you are combining, and it is there only one single problem, so that we can come up with the solution. Next one is the cross disciplinary. After discussing to the multidisciplinary, what is the cross disciplinary? So in this process, one discipline is examined from the perspective of another discipline. Suppose one discipline is taking the example, but that will be uh, checked by the suppose we are giving one task to some other person, so it is not like that that will be checked with the single one, that can go for the other discipline also. So maybe the vehicle is to be tested by the some other branches like computer or maybe the electronics or the some other things is electrical vehicle is coming, so electronics and electrical department can go to this. Just I'm taking the example of this, so this is the nothing but the cross disciplinary. And the third one is the interdisciplinary. Most of the part is which we are discussing, and we have just familiar with this word, that is interdisciplinary. So apart from this, this is an integrative process involving two or more disciplines simultaneously to bear on a problem. Okay, so whenever we will come with the one problem, so two or more discipline is come together, come under one umbrella, they are working to solve that particular problem. So that's nothing but called the interdisciplinary. The next one is the sequential or concurrent product realizations. So sequential and discipline specific concurrent design process for product realization are at best multidisciplinary, calling upon discipline specialists to design by the discipline based on this. Like the sequence, what exactly means we are discussing to the sequential and concurrent product realization. In case of this, we will go for the design by the different discipline, like the design mechanical system by the plant, select sensor and actuator and mount on a plant. Likewise, if we go for the setup of the any type of the power plant, so what exactly we can, there are lot many things are harmful things is also there. For like example of the boiler, we don't know how much temperature is there. So if you want to check, we can use that particular temperature sensors. So it is not required to the manually, then we use that pressure gauge, so ultimately we are getting that particular pressure and it is to be maintained. And the design, the signal conditioning and power electronics nowadays, we can control that system also, and we can increase or decrease the temperature if you are talking about the boiler. Design and implement control algorithm using electrical, electronics, microprocessor, microcontroller or microcomputer based hardware. So these are is nothing but is called the sequential or concurrent product realizations. The next one is the mechatronics based product realization. So we are just discussing about the product realization in the different cases in the different terms. This one is the system engineering allows. See, just keep it in mind in this one. The system engineering allows design. Design is the parameter where we have to initially we have to come together with the different dimensions, or just checking with the different parts. Analysis is to be there. So whatever the you have done with the design, that analysis is to be required by the different techniques. And synthesis of product and process involving component from multiple discipline, which we have already discussed about what exactly the multidisciplinary is. Okay, so mechatronics is the nothing but now you can consider as the multiply disciplinary action is to be there. And the mechatronics exploits system engineering to guide the product realization process from the design, model, simulate, analyze, refine, prototype, validate, and deployment cycle. So these are the part is to be based on the mechatronics based product realizations. Another is also there where the in the favorism of this mechatronics based product realization is the discipline is like mechanical, electrical, and computer engineering, as well as the information system are integrated through the design process so that the final product can be better than the sum of its part. See, whenever the multiple things is to be coming together, so the chances is to be error is more. So that should be optimized, that should be realized. So that mechatronics based product realization is to be compulsory. And mechatronics is not simply an multidisciplinary system, simply an electromechanical system, just a control system. This is all about the combine into the section. Now, you just go, you can see this flow chart, and based on this flow chart, I think it will be very easy to understand the concept of this design process. like the recognition. First of all, when you talking about the modeling, the three parts is there. One is the modeling and simulation, that initially that was the modeling, then we go for the prototype, and finally the life cycle and deployment is to be there. Okay, so we connect the from information from the model upgrades, and the modeling and simulation is to be initially, when for that we need to know the recognition of the need, and based on the conceptual design and functional specification. After the means, what are the need of this design, based of course, that we are going for the design based on our requirement or maybe based on the applications. And then we will discuss for the conceptual design, because we just identify the what are the needs of this particular product. So we'll go for the conceptual design based on the different analytical calculation and optimization techniques. And we go for the functional specification. Means specification means we have to design the basic things, like what are the capacity, what will be the materials, these are the things is to be decided. And then after we go for this conceptual, after that, based on that directly we'll go for the life cycle optimization, deployment of the cycle, right? Oh, okay, in this case. And based on after that first principle of modular mathematical modeling, that we have to go for this. We will go to choose the selection of the sensor and actuator, what are the sensor and the actuator is to be required to implement on this. Detailed modular mathematical modeling is to be required. Control design, design optimization. Based on this design optimization, we go for the prototype, or maybe using that. Now the technology is there, 3D printing is there, where we can go for the prototype model, and based on that prototype, we can show that to the customer, and if they are get satisfied, then we'll go for the final approval and go for the production. Okay, so these are the methods basically. In case of the we can go for the mechatronics design process. The next one is the evaluation of mechatronics as a contemporary design paradigm. So in case of this technology advances, which is to be related to the design, manufacturing and operation of this, in case of this, where that is to be traced through the industrial revolution, semiconductor revolution, information revolution. So this is all about the mechatronic system design that I have discussed. And now we'll go for the some of the example of the predominantly mechanical design, like you can see on the slide. This is the float valve, Watts governor, cam operated switch, thermostat, bimetallic strip. So these are the predominant example of the through the mechatronics design, which is the mechanical part is there. So these are the things there, the AD converter, amplifier, information, mechatronics revolution example, also the masterless cam grinder. That you will better understand, where the here the grinding wheel motor is to be there, and it is the integration of the different components in one section, that is multidisciplinary thing is there. And line positioner, cam rotating is there, cam and follower motor in case of the grinder. Okay.